Yes, sir.
Okay, thank
Yes,
you.
sir.
Sige, thank you. Oh, naka-join man lagi oh. Di sa man mo ni join Leia. Mag-check na ba kung attendance? Shared lang mo? Oh, naka-car malagi, naka-car. Sige,
Share daw, sir.
mag-check na ba kung attendance? Let me share my screen, oh. Maklaro ba akong screen?
Yes, sir.
Okay. Saan to? Joshua, kanang activity ugma kuan na sila tanan? Kanang whole morning? Canceled or naray specific na time? Kani 8 to 12 mga ba na eh? Whole morning raman Joshua no ang activity ugma. Murag busy si Joshua. Si kinsa may kuan makatubag para makakuan ko daan sa klase nga buntag nako.
Whole
Hello?
morning, sir.
Good morning. So ang afternoon wala na. No. Back to kuan na ta. So ang atong klase ugma is afternoon, di ba? Thursday. Okay, to afternoon no 4:30 to 6:30. Tama.
Yes, sir.
Sige, makamit pa dito ugma. Okay, 1 hour magunta karon. So I think mahuman siguro na to ni tomorrow ang psychometric properties, no? So by next week magkuan na ta. Cooling load calculation. No? Okay, so let's continue. So I think we have ended yesterday on the air quantity, no? So air quantity, so the air quantity required. So pilay gikinahanglan. Pila ka CFM, no? When we say air quantity, so the unit, no, that we are going to use is, or the most common, no, na unit Newton is CFM or the cubic feet per minute. So mamatayan niya, di ba? Or bisag purchase mo mga fan. So yung ina-apply capacity sa iyang kuanan eh. So in terms of CFM na siya. So the air quantity required of setting simultaneously the room sensible and latent loads and the air quantity required through the apparatus to handle the total sensible and latent loads may be calculated. No kay di ba si kaning size sa imong aparatus, kaning aparatus nga gimin niya dirhi, this is the cooling coil, no? So the size of the cooling coil will depend, no, on the air quantity or kuan vice versa, no, para nindot ang iyang nindot ang si tawag aning heat exchange, no, so mo matter na siya, and also the velocity, no, the velocity of air nga mo agi niya na siya requirement kung pila. as the room, no, sensible and latent load. So para kuan makibaw kag so ani nga room pila magyoy CFM nga gikinahanglan niya kay og although the temperature and the RH sa air nga supply mo is uh, sold siya sa range pero less amount to dili upon siya enough no to carry the heat no from the room ato ang condition. And think loads may be calculated using the conditions on their respective room sensible heat factor and ground sensible heat factor lines. So, ibaw naman taon sa ni si room sensible heat factor and ground sensible heat factor lines, di ba? So, kanay siya. So, ang ground sensible heat factor, so from the room, okay you know? Dili room, kaning mixture, no? The mixture, which is the mixture of the outdoor and the room, no? Or the turn air, no? And then the room sensible heat factor, so from the room to the supply air. Kanin siya, although, yeah, wait lang, napot, disconnect. Hello? Madugra, balik.
Yes, sir.
No. So, please bear with me na lang, no? Kay bigyan na to makuaning internet. So, bukalit gid siya og wala. Okay, balik ka. So, the ground sensible heat factor. So, kayo, gi-include na to dire. Include the apparatus, pero ang end niya, until the mixture. Mabito na nga, og sa graph, tanaw na to, diha og diha. Pero actually, atong mura na atong gi-consider diri ko kay kung wala pa ni siya bypass no wala pa nato consider ang bypass factor. The ground sensible heat factor is from this point up to this point, no, di ba? Yan na siya. But because there is inefficiency in the cooling coil or the EDP, the apparatus dew point, so air and the air that comes in contact with the cooling coil, which is the resulting point. So kanina blue, no? So muna yung lahin niya. So the intersection between the room sensible heat factor and the ground sensible heat factor is the supply air. So this color blue point here is the supply air condition. No? Supply air, no? Supply air from the apparatus. So kaning aparatus sa timanin na ninyo, ang aparatus nga giwin na that is a cooling coil. Okay. Disconnected na sa that I have posted in Google Classroom. So for your reference. Then kamo na lang sabay sa ko sa dapitan ng page. Okay, so let us continue. So we already know the Rome sensible heat factor and the grand sensible heat factor lines. Kasi siya na-locate. Then the intersection between these lines or the intersection of these lines is the supply air, no? So for a particular application, when both the Rome sensible heat factor and the grand sensible heat factor ratio lines are plotted on the psychrometric chart, the two lines intersection nila, the supply air to the space. So it is also the condition of the air leaving the apparatus, which is the mixture of the bypass air and the air that is or that comes in contact with the cooling coil. So just like the figure below illustrates what actually happens when these supplementary loads are considered in plotting the Rome sensible heat factor and the grand sensible heat factor. So what are these supplementary loads? No? These supplementary loads, di ba, tulo man to ka. Once we are going to calculate the cooling load, so there are three, no? There are three types of load. So the internal load, the external load, and the system load, no? So the system load, mo ni siya, no? Kaning supplementary loads. Dire siya na nabilong. So as the equipment, no, is supplying the air to cool the room, it also gains heat, no? Kaya nga naman, because of the motor nga ito ang gigamit. Fan, no? Sa fan. So the figure below illustrates what actually happens when these supplementary loads are considered in plotting the Rome sensible heat factor and the grand sensible heat factor. So this plot, no, the plot, so the psychrometric chart, makita na ninyo, depende lang siya kung arrangement mode, sa arrangement mode, no, sa inyong fan, kung asa siya na-locate. Kung blow through or draw through ba siya. Okay? So if this is the condition of the air leaving the apparatus, so what happens is dalawa. So di ba i-mention niya earlier nga the grand sensible heat factor lines and the Rome sensible heat factor lines, so when nag-intersect sila, so the intersection line or the intersection point rather is the supply air temperature. But what happens when we are going to consider the the secondary load? So mababa siya una, no? So ibang supply air, so dili na wala na bilong sa intersection. Niubos siya, no? Niubos siya. So going to the ang iyang temperature ni increase una. So what causes the increase in temperature? The fan motor gamit. And also the amount of moisture decreases, no? Or the humidity ratio decreases. So muna kaning from point 1, which is supposed to be the supply air condition. So naimon siya sa 2, no? Ni change siya sa second condition 2.2. And then from point 2, which is the supply air, muna ni ato ang supply sa 3. Di ba? Ang 3. So ang 3 mo ni siya ang atong sa room. No? Sa room na nimo. Then 4, which is the mixture. Then ada nimo og outdoor air. Then balik na pud ka. Then and then the cycle continues, no? Loop, loop. So point 1 is the condition of the air leaving the apparatus. No? Condition of the air leaving the apparatus, the mixture of
bypass and the air that comes in contact with the cooling coil. Then the second, the condition of the supply air to the space na, which is after na nimo nga i-consider ang heat nga na-gain sa imuhang supplementary loads. So line 1 to 2 represents the temperature rise of the airstream resulting from the fan horsepower, di ba? Fan horsepower and heat gain into duct. So muna na consider na to, nga supplementary loads or gitawag na og system loads, system loads. Heat gain kung ang imuhang ducting system is not properly insulated. So dako kay na siya og factor para maka-gain siya og heat. Pero og ang kuanong gyud na, so i-properly insulate yun na siya. Then point 3 is the room design condition and the point 4 is the mixture conditions entering the cooling coil. So the result of mixing return air and outside air. So the air quantity required to satisfy the room load may be calculated from the following equation. So we have the room sensible heat. Room sensible heat niyo. Okay, once anyway, once mag-calculate mo o cooling. So sa pag-calculate niyo sa cooling load, you have to consider the sensible heat load and also the latent heat load. Dili lang kay sensible lang. Both the room sensible heat load and the room latent heat load ang imong i-consider. Na-graph na. So i-discuss na to once pag-discuss na ta sa cooling load calculation. Right after mahumaning PDF topics. So niya sa psychometric practice, may sunod na topic na to. So next, so room sensible heat is equal to the M or the mass flow multiplied by CP, the specific heat, times the delta T, the change in temperature. So in volumetric terms, airflow rate in cubic feet per minute or CFM is below. So pila may kinahanglan ni mga airflow. So for air at density is 0.075 pound mass per feet cube. So evening density. So and CP is equal to 0.24. So we have the room sensible heat is equal to 0.075 times 0.24 times the CFM times the delta T over 60. So based from this equation, so imo lang gi-multiply yan si CFM ni Ari. Okay, mass flow na mass flow, Then this is the density, density times the volume flow. So it's equal to the mass flow. Diba? Multiplied by 0.24, which is the specific heat of air, CP, times the delta T, the change in temperature sa anong room, divided by 60. So this 60 nga denominator here is just for conversion purposes. So the RSH or the room sensible heat is equal to 1.08, which is the result from this constant. So 0.075 multiplied by 0.24 and divided by 60.
Hello, madungog ha?
Yes, sir.
Okay, padayon ta. Wala ko yung makita ninyo, no? Black screen lang. Padayon lang ta, no? Okay, so the air quantity required, no? So, through the air conditioning apparatus to satisfy the total air conditioning load will be calculated, no, from the following equation. So, the grand sensible heat. So, ang gamito na to, grand sensible heat, no? Then, using this equation, GSH or grand sensible heat is equal to 1.08 multiplied by the CFM or the cubic feet per minute of the airflow times the change in temperature from T4, which is the mixture of the outdoor and the room air, minus T1. So, asam ng T1, this is the uh, air conditioned leaving the apparatus, no? Which is a mixture of the bypass, no? The bypass air and the air that comes in contact with the cooling coil. Di ba? Manay T1. So T4 minus T1. So the CFM for that is CFM o atong computer play quantity, no? Of air nga dapat atong gamit kuanon para enough siya, no? Para enough siya nga makasatisfy sa requirement sa total nga air conditioning load. So CFM is equal to grand sensible heat divided by 1.08 times T4 minus T1. Okay? So, makalculate mo ninyo kaning grand sensible heat. So, for all practical purposes, the required air quantity supplied to the space is equal to the air quantity required through the apparatus, neglecting leakage losses. No? Kuan ko no? The required air quantity supplied to the space is equal to the air quantity required through the apparatus, neglecting leakage losses. So, parihara na sila. No? Same ra. Kung ato i-neglect. Pero og na-leakage sila, so syempre mas dako-dako gid ang air quantity nga imong inhanglan sa aparatos para nag-abot niya sa nag-supply niya ngadto sa room. So kuha na. Pero syempre once design ka, so you don't need to uh, you don't need to consider the leakage, di ba? Kaya magbutangan ni mag-leak ang kuan. Okay? So in well-designed tight systems, the difference in supply air temperature and the condition of the air leaving the apparatus. So T2 minus T1. So T2 is supply air, no? And T1 is the air leaving. So it should usually no more than a few degrees. So gamay ra gina siya. No, gamay ra na. Usa gito yung naka-cause kanong na-difference ni si T2 ug T1. Mr. De Los Reyes. Magwa ko madunggi.
Yes, sir. Yes, sir.
Hello.
Yes, sir.
Dunggan ko. Sige.
Magputol-putol sa kuha, sir.
How about kuan? Mr. Vidor, no? What's the reason, no? There is a change or there's a difference between the temperature in the supply air and the temperature leaving the apparatus. Hello? Madungog ra ba?
Yes, sir. Yes, sir.
Okay, babalik ta. Mr. De Los Reyes, no more, ikaw may nakadungog. So, unsa may rason ka ha, nganong sa ganito rason, nganong naay difference sa T2 and T1. So, T2 is the temperature of the air, supply air, no? And T1 is the temperature of the air leaving the apparatus.
Niyagi mag-cooling coil, sir?
Nope. That's not That is not the answer, no? So remember, unsay pasabot ano nila, unsa ni si supply air and unsa ni si air leaving the apparatus. So when we say air leaving the apparatus, basically supply air na siya. Supply air gihapon gyud na siya. If and only if, so unsa man nganong ngalahi man siya. How about Mr. Sukurin? Mr. Sukurin, can you hear me? How about Miss Ugat?
Yes, sir. May lag ko, sir.
Lag. Okay, can you please answer Mr. Sukurin?
What's the question, sir? Itong supply air
What's
and
the
room.
reason why there is yes.
Sa
What
kwan,
could
sir,
be the reason
bypass.
why there is a difference in temperature?
Sa bypass,
Nope,
sir.
that is not the answer. No. No. The bypass is kwan. There is a difference in temperature sa air nga ni contact, no? And the temperature after sa or leaving. The temperature leaving and the temperature of the cooling coil. Ang answer na bypass, ganun na difference na sila. Tungod kay ni bypass. But the question is, so what could be the reason, no? Why there is a difference in temperature between the supply air and the air leaving the apparatus? How about Miss Tubak? Excuse me. Miss Tubak, can you hear me? So 10 points for those who can answer the or answer this question, no? 10 points sa quizzes nga kuan. So anyone who can answer? Okay, balik Mr. Sokoren, kuan lang, no? Unmute kay mas maayo na.
Sa air leakage, sir.
One of the kuan. One of the reasons, so early cage, pero ang uban sa pa man. One of the reasons na siya.
Kanang heat transfer, sir. Loss.
Okay? So the answer is the supplementary load or the system load. So unsa may mga supplementary load or system load? So the load, no, the heat, no, gikan sa fan sa imuhang blower, I mean motor sa imuhang fan, no, or sa blower imong gikuhanan. And then the heat gain sa ducting if the ducting nimo is dili siya ingana ka efficient ang ihang insulation, and also katong possible pod air leakage. Okay. So 3 points lang, no, kay 3 points for Mr. Sukurin kay usa ra man sa kuan. Pwede ra to ningon siya og supplementary loads. Supplementary loads that covers kuan the all the factors or itong mga unsay nasulod. Okay. So akong klaro na supplementary loads ang nakaingon na niya nganong naay difference between sa T2 and T1. Kaya di ba gi-mention to niya earlier nga the intersection between the ground sensible heat factor and the room sensible heat factor is the supply air. Pero in this case, if we are going to consider the supplementary loads, so nanay temperature change. Mo ni si T2 o si T1. Okay? Na sabtan ra ba?
Yes, sir.
So ato lang i-take note, no, Mr. 3 points. Lionel Dave Socorino. Okay, so next. So the difference in temperature between the room and the air supply to the room determines the amount of air sensible and latent load. So kaning duha ito ang i-consider, no? So base good sa mag-calculate sa cooling load calculation. I mean mag-conduct ang cooling load calculation, no? So sensible and latent loads yun na siya. So as this temperature difference increases, so the required air quantity to the space decreases. Di ba? Temperature difference kung increases, the space decreases. Magagamay na lang. Ganon. Pasabot, bugnaw naman siya. Sa supply. So pasabot, ang imuhang supply kita hay, mo naman kay set point ana or it depends on no sa unsay application na nga room. For example, mga sinihan. So kasagaran na sa 18, no? 18, 19 or mga 20 uban. So abutan na to 19, no? 19 degrees. Then the supply air temperature is nasa 15. So na kay specific nga amount air nga imuhang ikuan na. Pero once magkaanam og kaubos ya, let's say ang imuhang supply air temperature drop to 10 degrees Celsius na. So syempre, less amount of air na imuhang kuan, less mo decrease no ang ihang flow rate nga imong gikinahanglan nga naman. So syempre, mas bugnaw naman ang hangin nga imuhang gi-provide or gi-supply. So that means less na ang iyang, so mas dako ang iyang kuan, dako ang iyang, I mean murag di na kinahanglan ka og dakong amount no sa air kung mas bugnaw na siya. Pero dapat na gyapon go circulation, no? Pero less na lang siya. Mura gud na sa ikaw kung mura na og kitay ikaw kanang kung tingigang, so magkinahanglan ka electric fan. Yung tingtugnaw, si siyempre bababa na yung temperature, so ang imuhang gikinahanglan nga airflow gamay na lang. Ay kung na sa tingtugnaw, electric fan pagid ka. So, dili na, no? So okay, mo bugnaw na mo kayo, then dili na masud sa comfort nimo, no? Ya ting bagyo niya baba kayo yung pan yan na ba no? Ya mag-electric fan gihapon. So yan ang concept, no? So as this temperature difference increases, pwede ra gugmayon ka og dili temperature difference. The temperature supply, no? Supply air temperature decreases, no? So the required air quantity to the space also decreases. Pero when we say temperature difference, increases na siya, no? Increases, the required air quantity to the space decreases. So this temperature difference can increase up to a limit where the room sensible heat factor line crosses the saturation line on the psychrometric chart. No? The room sensible heat factor line crosses the saturation line on the psychrometric chart. So if it is assumed that the available conditioning equipment is able to take the air to 100% saturation. So kana kung atong gi-consider siya nga 100%, no? Sa air ang saturate. So the value of T4 is determined by heat and trial. So when the supply, return, and outdoor air temperatures are known, equation below can be used to calculate outside air percentage of the mixed air temperature. So hindi na ito mahibuan, no? Especially kung mag-sizing ka o ducting sa return o ducting sa fresh air. So sa may size nga imong gikinahanglan. So yan no, para makaibaw ka, then pila ka percent, no, sa outside air. So using this equation, the percentage of outside air is equal to that temperature of mixed air minus the temperature of the return air over the temperature of outside air minus the temperature of return air. So using this equation, so kuan ka o maka-decide ka pila ka percent sa outside air ang imong emiton. Okay, so this equation assumes that perfect mixing occurs. Degree Fahrenheit. Then HW is the latent heat of vaporization, which is 1,059 BTU per pound at 60 degree Fahrenheit. So this 16 multiplier here just for used for conversion, no? So from minutes to hour. So we have sample problem here. So sample problem. Consider an interior room. By the way, do you have class after this one? After this meeting? Or after this time, or for 30? No, na may klase for 30. A and B. Or we can just continue this tomorrow, no? So, hapit na mahuman. Maybe tomorrow para next meeting, kuha na. Cooling load calculation. Then, after sa cooling load calculation, so maka-start na mo o design. No, sa imuhang centralized air conditioning or DCS, district cooling system. So, by now, dapat naana mo'y idea asa mo nakakuan na ba ta? Is this kuan your first time nga mag-design o kuan kay murag first time pa ninyo no mag-design og nang nay plano ba as building plan? Hello? Oo, okay. Kuan man dito.
Yes, sir.
Duha man gud ni. Duha ka subject ang maigo ba kay itong sa mga ni-graduate karon nga kuan ang sa Hvac nila nga building plan same ang ilang gigamit sa fire protection, no? Okay. So karon wala man may kagi og fire protection, no? So kato itong ni-graduate. So ang mahitabo karon mo secure na mo daan o building plan, no? Kaya wala pa man mo. So which is kanang building plan mo inyong designan og air conditioning system. So DCS lang pwede DCS ka ng multiple buildings. So dili lang kay usa ka building, kundi multiple maghimo lang kag plant, no? DCS plant or pwede na kung usa ka building basta kay dako ng building. So ang requirement nako last time last year no is dapat 1 hectare siya ang total floor area. Total floor area means i-add up nimo ang floor area per per floor na siya. So first floor yan ang floor area plus second floor yan ang floor area. So maabot siya og 1 hectare. Nga na. Pero karon pwede ra og kuan lang bisan og unsa ra inyo ang ma-secure basta kayo tanaw ninyo ha nagkinahanglan siya og dili lang ng balay ra ha kay mga split type ra man na window type kang magkinahanglan siya og kuan centralized ang magkinahanglan siya piping system. So secure na mo daan karon para after sa ato ang pwede ra pod og while nag-discuss na sa cooling load calculation magkamulo na pod mo og calculate. Okay? Okay ba?
Yes, sir.
Yes, Mr. Araraw.
Sir, asa may maka-secure og mga building plan, sir? Saan naman na, sir?
Last time di ikakuan naman ni ho nga nakakuan ng subject ka no ikaupat man zero mo. So ang katong mga previous gyud nga kuan ang gilang gipangayuan. Pero during our time mo share lang pud ko no. During our time sa kami pa kuan way back 2010 or 2009 may ana to no nga time na design may uguan. Kami gyud nahimo sa building plan. Pero just for kuan na lang. So sa pag-practice na lang no. Practice sa profession kay dili magkita mo himo sa building plan good. So ang ato lang is we'll just have to coordinate with the architects and other engineers no. So for now, so naman siguro mo kailang ang mga architecture students ang gibuhat sa previous nga mga batch is ni-secure sila nangayon sila og copy sa mga project sa mga artist students. If wala, then pwede ra pud mang-download no na may mga available ana nga kuan mga usa kay naka-CAD na siya para dili na mo mag-trace sa CAD balik. Or kung wala naka-CAD, pwede ra man na og naka-PDF man na makopy into convert inyo into CAD drawing no. So mo na inyo hang himuan. Insert lang na niya, insert PDF niya. Mo CAD na siya. Pwede na mo ma-search din or pwede na mo maki-coordinate sa mga architecture students. Okay ra ba natubag ba Mr. Araraw?
Yes, sir.
Katong previous pag yun, mas nauna, ako yung nahatag o building plan pero ang ko is may uniform may uniform ba magpapariha. So mas mayo nang lahi-lahi mo. Okay. So individual na siya nga project. Then for those don't have laptops, so pwede ra mano-mano. Mano ninyo and then i-scan lang ninyo, mo inyo i-submit. Pwede ra pod kung just in case nga mag face to face na, so no need to scan na lang. So i-compile na lang ninyo ang plano. Pwede ra, yes Miss Duterte. Pwede ra. Any other questions? So I suggest no kuha na lang you have kaning yellow pad no while mag-discuss ta sa calling load calculation kay para anam-anam mo. Para ma-check na to ang inyong progress. Okay? Pwede mo share sa inyo katong mga output last time.
Okay, sir.
I-cycle lang ito mga lintanan o katong wala diligid mga kuan. Pero much better mang gyud og inyo nga kuan kay para amoy makabuot no. Pero kung mga ginangay po ang giingon kung gamay na siya building na diligid kuan na og tanaw ninyo mga munisipyo bitaw add mo another building type sa building para ma-district siya no. So mahog district link system na ito ang gikuan so centralized or gihapon. Okay, na sa tanra. Yes, Mr. De Los Reyes.
Excuse me, sir. Balik lang ko, sir. Pila galito? Wala na may answer no limit, sir. Kung pila ka hectare, sir?
Yes. Wala na limit ko uga to mo i-limit na yung iban nga mo yun nga 9 ano ko nila 9,000 square meter which is wala ka abot sa kuan 1 hectare unya. Pwede ra gud po to no may ana ba kato nag-set lang ko kay para dili ma-unfair na mag-iban nga dako ra uban nga tami. Pero depende man na ninyo no sa inyo pagkuan asa mo maka-secure. So gamitan lang yung pag ma-discarte. Okay?
Okay, sir. Thank you, sir.
Napabay pa akong ana. Okay, so for the attendance, dansa,
Present,
Grisor,
sir.
Grisor. Wala, no? Hello? Madungog lang. Sige, kay nawa, monggod. Balik ta. Dansa, present, agrisor. Alaban.
Present,
Asas.
sir.
Araraw. Asas, no?
Present, sir.
And then, Ayop.
Present, sir.
Balbido. Balbido. Busbos.
Present, sir.
Kagaanan.
Present, sir.
Isa mo to?
Present, sir.
Busbos, no? Castillon. Doldolia. Doldolia na. Adara. Duterte.
Sir, present, sir.
Gamban. Gamban. Hibaya. Israel.
Present, sir.
Humawid.
Present, sir.
Lanaria.
Present, sir.
Lulong.
Present, sir.
Lumutos.
Present, sir.
Mar.
Present, sir.
Milianes.
Present, sir.
Opelinia.
Present, sir.
Orias. Pasagad. Ah, sagad wala no? Ranes,
Present, sir.
Kanyuwa,
Present, sir.
Rikerme,
Sir, present.
Reyes,
Present, sir.
Saludo,
Present, sir.
Simborio,
Present, sir.
Tubak,
Present, sir.
Ugat,
Present, sir.
Villa, Vidor,
Present, sir.
Vitor,
Present, sir.
Belarmino.
Sir, present, sir.
Okay, for 4B, we have Abada, Balagot,
Present, sir.
Puntia, Abansag pa di ay,
Present, sir.
Buntia, Kandog, Concha,
Present, sir.
Quino,
Present, sir.
Dagangon, Dano,
Present, sir.
De Los Reyes,
Present, sir.
Malikon lang ako si Marquez ha. Elio Rimo,
Present, sir.
Istorioso,
Present, sir.
Zelda, Flores,
Present, sir. Present.
Inita,
Present, sir.
Inita, Tinting,
Present, sir.
Hamisula, Layar,
Present, sir.
Mag-Uyon,
Present, sir.
Manlawi,
Present, sir.
Makiling,
Present, sir.
Marapaw, Mapaw, wala no. Ubo,
Present, sir.
Pasam, kisa to, yung ubod to, ubod eh. Payot,
Present, sir.
Present ko, sir.
na si Marapaw. Then,
Pasamba, sir.
Bayot.
Present, sir.
Oh. Munida.
Present, sir.
Salumo.
Present, sir.
Yes.
Present, sir.
Sukuri.
Present, sir.
Oh. Timbal.
Present, sir.
Tumo.
Present, talo, sir.
Tumo.
Present, sir.
Valyes Ortodaso.
Present Padilla, sir.
Si Tumo po to. Present Tumo. Okay. Naday. So, thank you. Thank you for attending this
Pasamba, sir. Present, sir.
one. Think that's all for today. Okay na. Nakuha na.
Talo, sir. Talo.
So, okay na. Katong ni-mention ni chatpod na okay na to. So, ang wala pa, si Bontandog, Dagangon, Peselda, Hamisula, Mora. Ito ba? So, that's a wrap for today. So, thank you for attending this meeting, even though the internet connection is unstable. So, your class dismissed, no? You're free to leave the meeting. So, God bless everyone.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Yes, sir. Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.